Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about the BigInteger Constructors. Now I've done a few videos on BigInteger class, and I was thinking that it would be a great idea to do prime numbers and figuring out prime numbers, but I just got going down a tangent. I really didn't need to, so I'm just scrap those videos and coming back here to just covering the BigInteger constructors, then the BigInteger methods after that. So the first thing we'll do is go and open up our web browsers to my website, javacjava.com, select Java Tutorials, and scroll all the way down here to BigInteger Constructors. The BigInteger class is one of my absolute favorite classes in Java. I've been fascinated with large prime numbers and cryptography for decades, and the BigInteger class allows us not only to create really large numbers, but also to perform many standard arithmetic operations on those numbers. The largest of the Java primitive data types is the long type. Now we can create a long type variable within the range of the negative number here to the positive number there. And while that may seem like a huge number, that is only a total of 19 digits. Now, the largest prime number found at the date and time of this tutorial is over 22 million digits long. So needless to say, the primitive data types are not going to cut it, and BigInteger is going to become our new best friend. Now, the BigInteger class allows us to do some really cool stuff, but with that comes a lot of overhead. It is important to understand that the actual BigInteger objects are immutable, which means they can't be changed, so their value cannot be changed once they are created. The result of performing operations such as addition, subtraction, multiplication, division, etc. all create new immutable BigInteger objects. Per the documentation, the range of numbers that can be stored in a BigInteger object is on the negative side 2 to the power of that number, and on the positive side 2 to the power of 2 billion whatever. You also need to be aware that your computer will use a lot of heap memory in creating these objects. Now the heap memory of course is created in your RAM. Now in many cases you will need to use the command flag of -x ms. Question marks means how many gigabytes of RAM you're going to allocate to the Java virtual machine in order to do all these big integers. Okay, let's talk about the first constructor here. We pass it a parameter of a string. So this returns a reference to an immutable BigInteger object. This constructor is the simplest one. Just pass a valid number as a string representation for the parameter. If the string parameter cannot be translated into a valid number, then a number format exception will be thrown. Let's go ahead and jump into some code here. And actually, let's come down here and highlight the code. Go. And do a Control-C, or let's copy it and move our browser off screen here. And now I've got a shortcut to the command prompt on my desktop, but if you don't, you can create one really fast by right-clicking, selecting New, Shortcut, typing in CMD next, and Finish. It's just that easy. Let's go ahead and open it up here. And then let me do something real quick here. I have to pause the video and come back. Alright, so the first thing you want to do is type in javac, which is the Java compiler command. And you should see all this stuff scroll by. However, if you receive an error message, watch my tutorials on installing and configuring the Java kit. You want to make sure you get that done properly before continuing there. Okay, the next thing you want to do is type in CLS to clear the screen, then CD space / CD is short for change directory / tells it to go to the root. I'm going to make a directory called Java off the root with the MD command. And I already have that folder, but if you don't, it'll go ahead and create it for you. I'll change directories to the Java folder. And then I'm going to make another directory here, and I'm going to call this BI, short for BigInteger Constructors. Okay, let's change directories to that folder, and Notepad BI Constructors.java. Okay, let's go ahead and paste all that code in there, come up here and save. And let's see, the first thing we'll do is just go ahead and clear our screen again, javac, that source code file we just created, compile it, and then Java to invoke the main method of the BI constructors class. Okay, so the first thing we want to look at is just basically up here we created the new BigInteger object, passed it in the parameter of this string right here, right? And in our output we got this big number right here, 37 digits long. So that's pretty simple there. That creates a new big integer object there that this bi from string is actually pointing to, or referencing, I should say. All right, let's go ahead and just clear that out. Let's come up here and save this. Let's clear our screen. We'll recompile. Yeah, let's move this up a little bit. And our screen, let's rerun. And let's come back to the website here real quick. The next constructor is going to require a little bit of explanation there. We pass a byte array, and it returns a reference to an immutable big integer object. The constructor is expecting the byte array to be ordered BigEndianStyle. Okay, so let's come over here and take a look at the source code. And I have created a very simple byte array here, 3 bytes, 3 indexes. Index 0 contains 0, index 1, 0, and index 2 contains 127. And just to take a look at that, we create the new big integer object by passing it the byte array there in that constructor there. And then we'll display it to the console, display its length in digits, and display its length in bits. Alright, so what we've got here is here's 127, 3 digits long obviously, and 7 is its bit length. So what does it look like in the individual bits? Well, we'll just go over here to the to our calculator. Make sure we got programmer selected here. And so this is 120, wait, clear. We got 127, right? It's like binary, and as you can see here, it's 7 bits long, and they're all set to the number 1, right? A Java byte, as you know, is a signed byte, so its value goes from -128 to 127. But that does not apply to this constructor there. It will not work. If we, for example, put in a negative number like -56, right? Let's go ahead and save that. Let's rerun this. And you can see that now it produced the value of 200 with a bit length of 8. Okay, negatives just don't work with this constructor. All right, so let's go ahead and we'll just put this value back to 127. Right, and let's come back up here and save. Let's clear our screen, recompile, rerun. All right, so we got our 127 back in there. As we know, it looks like this in binary and looks like that in our bits. So now, BigEndianStyle. Now we've got a 1 here for the second value, right? Or the second index, and this is the third index here, even though they have a 1 and a 2, right? Because we start off at index number 0. And so if we do that, our new value is 383 decimal. So let's come over here to decimal. I come back to binary and pay special attention that we got these. Hold on, just a second. Who's working this calculator? So we've got basically 7 ones here. All of those first 7 bits. Those BigEndianStyle start read from the right to the left. Well, the binary reads from the right to left anyway, but big endian basically means that this 127, this last byte, will be the furthest written over there. Okay, and so by putting in 383, I believe that was the number there, right? 383, and then we convert that to binary. You can see those bits are set, and then this bit is set right here. So there's 8 bytes in a bit, and you can see all 8 of them are set here. The first, we read this from right to left, so we got the first 7 set as 7, the 8th bit is set at 0, and then we start our next byte over here, which is just set to 1, right? So if we set this, for example, to 127, right, we are going to end up with reading from right to left, 7 ones, and then a 0, followed by 7 more ones. So let's go ahead and save that up here. Okay, let's run this and compile. There we go, right? So we ended up with now 32,639, right? And if we go ahead and let's just do clear. Let's clear this and do 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right, now we convert that to decimal there. There we go, we got our 32,639, okay? So that's basically the way BigEndian works. So we're done there. This I was going to do something with, but I think I'm going to skip it there. I'm just going to say it produces just a really large number, but it'll take too long to explain what I was going to originally do there. Let's move on here. You can also it's a very interesting thing about this particular one there. So let's clear our screen here. I'm going to show you something up here real quick. As I just demonstrated, negative numbers don't work. But what does work is like regular unsigned bytes. So if we come up here and save this, and we compile it, we are going to get an error, right? Conversion, lost conversion from int to byte, basically, right? So what do? We just go ahead and come up here and we'll cast this to byte, right? Which is really strange. You really shouldn't be able to do this in Java, but it works perfectly, actually. It compiles and it runs, and we see our value is 255. We have 8 bits, and so as you may or may not know, if we take, see, we're in decimal right now, 255, and we convert that to binary, you can see all 8 bits are set to 1 there. Okay, so that's kind of interesting too as well. In addition to that, we can throw in hexadecimal values too as well. Now FF is equivalent to 255, and if you come down here, you can see that after this big long number, we got 65,535. If we go up to hex and we go FFFF and we convert that to decimal is 65,535. Binary is 16 ones, right? And you can see that's there. Okay, so that's basically about that there. That's the things you really need to know about that. Now what we're going to do is we're going to talk about the next one here, but let's get rid of this, all this stuff here real quick there. We'll have to, of course, put back in our type declaration there and our type declaration here. And let's just save this and go on to the next one here. Okay. So you might be asking, well, how do we do negative numbers then in this byte array constructor type thing? And that's what the next constructor does. We put our sign in there and we do our magnitude. First parameter represents the sign of the number, -1 for negative, 0 for 0, and 1 for positive. I highly recommend never using 0. The parameter just makes 0 sense. Now this constructor is expecting the byte array to be ordered BigEndian style, just like the constructor above. Let's go ahead and take a look at this here. So right now I'm passing in 1, which means it's positive, and of course we still have the FF and the FF, which is 65,535, just what we'd expect here, 16 bits long. Now let's go ahead and change this first parameter to -1. Come up here, save this, recompile, rerun. Now we get -6,535, but our bit length is still 16, so you can see there's not a bit in there holding a negative value or anything like that. Still just 2 bytes long. Yeah, so that's how you can do the negative number there, right? If you wanted to do -56 like we originally did up there when I was screwing around with the other one there, right? What will this do? Is this, you might be thinking, oh, can I do this? And the answer is no, you can't do this. So that -56 will still translate to 200, and then that -1 parameter there will tack it on there. So what do? We just set this to 56 positive, right? And then we can actually get our negative number from the byte array there, which will be -56, 6 bits long. Okay, now let's talk about this 0 and when I think it's so incredibly useless. Let's just pop in 0 there. Let's clear our screen. Let's compile. And look at that. It compiles. And now, guess what? We get a runtime exception. A signum magnitude mismatch. Basically, if this is 0, the byte array has to hold a total of all zeros too. Anything that does not on a 0 there is going to produce a error. Right? So there you go. You get 0 and your bit length equal to 0. Right? But couldn't we just put in 1 there, right? I mean, since technically 0 is not negative, we all know from math class it doesn't require us to, you know, oh, what did I just do? Dang it. I don't know what I just did. I think I just, there we go. All right, so let's put in, we put in 1 there. I think I did new instead of save there. Let's clear our screen, recompile, and of course we still come up with 0. So we're all good there. So that's why I say the 0 is just ridiculous, especially when I start talking about, like, for example, there is in the big integer class, there is a dot uppercase 0, which is essentially a constant that is basically holds that value. Much easier ways to create a big integer with the value of 0 than ever passing it a byte array plus this 2 array thing there. Okay, anyway, so that will pretty much take care of that. That's how you can do negative numbers passing in byte arrays. Let's come up here. Let's see, did I just... No, everything has got a declaration, so I think we're good there. Let's clear our screen, recompile. On to the next constructor. Next constructor is pretty simple. I imagine it has something to do with cryptography, but you pass it in the number of bits and then a random object. And this constructor creates a random big integer number somewhere in the range of 0 to 2 raised to the power of the num bit parameter minus 1. And the random can be just any random object. The random class is contained in the java.util package. And of course, it's good to say the big integer class is contained in the java.math package. So here, I'm passing it the parameter 128. So we're going to get a random value of a big integer that's at least 128 or less bits long. Okay. So as you can see right here, here's the number here that it came up with first, 128 bits long. Let's hit the up arrow again, see what we get this time. And again, and that one was 127 bits long. And you know, we can get even numbers, we can get odd numbers, it just doesn't really much matter. It's just kind of a random number generator. Not a whole lot, maybe there's a whole lot of use to that, I don't know, we'll see. Anyway, let's move on to the next one here. Let's go ahead and get rid of this. Okay. Let's clear our screen. Talk about the next one here. The next one produces a random big integer, most likely prime number, somewhere in the range of the specified bit length. So the bit length, if it's 128, it's going to produce a number that is most likely prime. Now, most likely prime basically means that it uses what's called the Miller-Rabin primality test, and I will get into the details of that with the isProbablePrime method in a future tutorial. But just know that the higher certainty that we pass up here, the more likely you're going to get a prime number. In the 80, and I say in most cases, use 80 or greater for the certainty, and you will most likely get a prime number back. Nothing to do with percentages, but I'll cover that in a future video with the isProbablePrime. And of course, you pass in a random object to there as well. So let's take a look and see what that one does. So 128, 80, and a new random object produces this number. 128-bit length there. If we go up again, right, it produces another one. Now you can see all prime numbers have to end in a 1, a 3, a 7, or a 9, so we're looking pretty good there. So it'll just produce random, most likely prime numbers. And really, there's a super high probability that these are prime numbers there. Okay, so that is that one there. Now let's just cut this one out and talk about the last one. The last one's got a kind of maybe an unintended consequence there, but it's actually pretty cool too. So let's clear our screen on this one and run it and bring the site back over. So the last one here, we pass in a string parameter and a radix parameter. This returns obviously a reference to a immutable big integer object. Now, as far as I'm aware, the radix parameter is simply the base of the number that the string will represent. I've searched for a published list of all the valid radix values, but I've not found one thus far. Some of the valid radix values that I know of are 16 for hexadecimal, 8 for octal, and 10 for decimal. So, taking a look at this, right, you're all most likely familiar with like seeing hexadecimal numbers and internet colors and stuff like that, but FFFF is a decimal equivalent of 65,535. So we pass it in the string number of a valid hexadecimal number, and then 16, which represents hexadecimal or base 16. We get 65,535, bit length of 16. Now, let's go ahead and put in some other random numbers for hexadecimal values here, right? And let's just copy this, and we'll just paste this all up there, right? And save. Now, you can also think of this constructor as a super easy, almost like a method to convert hexadecimal to a decimal string. And that's exactly what we're doing here. So if we come back up here, compile this, and run this again, this hexadecimal value right here is equivalent to this decimal value right here. So it's kind of an interesting little byproduct. They didn't design it that way by any means, but if you want a quick way to convert hexadecimal to decimal, just use this constructor on the BigInteger class and store the string value of this to that, right? So anyway, that is the last of the BigInteger constructors there. I'm going to go ahead and minimize all this stuff and leave you guys with some quick final thoughts. So stay tuned for my next tutorial where I will discuss how to use some of the basic arithmetic methods on BigInteger objects. That concludes this tutorial. Thanks for watching.